Hi. As a follow-up from one of my previous videos on building Flask APIs on Python, I thought I would create a video to show you how you can deploy a Flask application using AWS Beanstalk. Now, in this particular example, I'm going to be using a REST API, but the process is identical if you just take a vanilla Flask web application. Now, in terms of the video itself, the agenda will take a quick tour of or an overview of AWS Beanstalk, and that's handy if you have not used Beanstalk in the past. Otherwise, you want to skip ahead, and then we'll cover how we can create an application on AWS Beanstalk. And in doing so, we'll take a look at the web-based console, the AWS Web Console. We won't be doing any scripting using anything like the CLI, so it's just the GUI, web-based GUI that we'll use. And then finally, once we have created an AWS Beanstalk application, we then will take a look at how you can upload your custom Flask application to AWS Beanstalk. And again, we won't be using the Elastic Beanstalk's CLI, the command line interface. We will use the web-based GUI, and we'll also package the Flask application and upload that using the web-based GUI. So again, it gives us an idea in terms of what the CLI possibly will be doing under the hood. So we'll learn a bit in terms of how AWS Beanstalk deploys application and packages application in that way. So that's the scope for this video. So let's dive in. So first off, what exactly is AWS Beanstalk? Now, AWS Beanstalk, I would say the whole idea of AWS Beanstalk is it's part of Amazon's set of compute services, and the real idea behind AWS Beanstalk is it simplifies that whole process and pipeline between us deploying, managing, and scaling our application. So the general idea is that it lets us focus on our application and less or allows us to be more focused on the application, and we don't have to worry a lot about managing and scaling infrastructure, and that's all the services that AWS Beanstalk does for us. So it does that using this idea of a managed container, and specifically our container stack that we are going to be looking at is for Python, but obviously AWS Beanstalk provides a multitude of other very popular web-based stacks. So again, AWS Beanstalk is really intended for delivering web-based application or application that uses web interfaces like REST APIs. So again, it's still based on HTTP based protocol, so it's an ideal candidate for something like AWS Beanstalk. Now, AWS Beanstalk, there's this ongoing debate whether it's really a PaaS, platform as a service solution, or more of an infrastructure as a service or IaaS based solution. And I would debate that, in my opinion, Beanstalk is very close to being a PaaS-based solution, because under the hood, Beanstalk leverages other infrastructure as a service capabilities like EC2, for example. And instead of us worrying at the infrastructure level, at an EC2 level, it allows us to build applications and deploy it using Beanstalk. So again, it's all about simplifying that whole deployment and allowing us to really deliver applications in a much more agile way. And also AWS Beanstalk provides us a lot of other capabilities for us to scale the application, provide load balancing, a mechanism to provision application, health monitoring, auto scaling, and various other services. So I would say AWS Beanstalk is a very good candidate for building web applications and REST API. So that's kind of like a really quick overview of Beanstalk. But to bring things to life, let's actually go ahead and with our step one, let's go ahead and build the Beanstalk application. So if you log into your AWS Web Console, you'll find that under the compute set of services, you'll find AWS Beanstalk right there. So you'll want to click on that. And let's go ahead and create a new application. So keep in mind that AWS, they're constantly changing the GUI, and even at a particular point in time, I guess through things like A/B testing, you'll find different versions and look and feel. But overall, the flow should be very similar or very consistent to what I'm doing right now. So let's just give this a name. So let's call this demo EB1, and try and keep the name unique, and we'll see that why you want it unique in just a bit. On the next screen, or part of the set of wizards that you'll come across, you have the option of selecting whether it's a web server environment or a worker environment. Again, we are just building an API or even a standard web application, so you'll want to choose create web server. And here's where you actually get to select the platform. So you can see that all the major or the most popular platforms are covered. You have Go, Tomcat. We are obviously going to be using Python and Java. I mean, for folks who are on .NET and Java, obviously, and Node.js. So again, all the major popular ones are covered, as well as you have the ability to deliver solutions using Docker. So that's pretty exhaustive in itself. So go ahead and select Python, and behind the scene, it'll select the Python 3.6 version at this point in time. And you have the option of selecting whether it's a single instance or a load balance with auto scaling. For development and R&D kind of like learning purposes, single instance will do, but just to have a more complete conversation for the demo, I'm going to be selecting load balance with auto scaling. Again, keep in mind, if you do select with load balancing, your cost will increase. So bear in mind, you'll want to shut down or terminate the service once you finish playing with it. Later on, we'll go ahead and upload our applications, but for now, let's just use the sample application. And we can leave much of these policies as is, so don't worry about it at this point in time. So click on next. And based on the name that we selected initially, it's created some defaults for us, and this is why I mentioned you want to check when you check for availability, you want to ensure that it's a unique name. Click on next, and again, keep in mind that this is a friendly environment name that will pop up in the GUI and in other screens. Now, in terms of additional resources, a very common model for building AWS Beanstalk is you obviously have your web application or the REST API kind of having a backend to it. So some form of relational database and various others. So if you do want, you can create an RDS, an Amazon hosted database service along with your application. But my suggestion would be that you don't do that. Instead, you create the RDS separately. So under database, you can go ahead and create your RDS services separately. Otherwise, it's if you don't do that, it kind of ties it or ties your RDS lifecycle into your application, and that's not necessarily what we would want in most circumstances. So it's good to keep it independent. So I would suggest don't click on this, and instead, if you did require an RDS, provision that separately. Again, we are going to keep this video very simple. In production or in a real world, obviously you will want to have its own VPC, but I'm going to skip that for now. Here we will select or we'll enter some of the other details. Again, trying to keep this fairly light, so we'll just use the default of a T1 micro. Again, this is just for a demo purpose, so that's more than sufficient. And then you can select your EC2 key pair. Hopefully it's a key pair that you already have. I'm not covering how you can create key pairs in this video, assuming that's something you're already familiar with. You can leave much of this as is, and then everything looks good. Let's click on next. Here it's a good idea to set some environment variables which you can use within your application. Again, for the video we won't be utilizing that, but typically things like, say for example, you have an RDS and a database engine such as say Postgres, and you want to keep the connection settings like the database name, the server name, etc., and pass that on as environment variables, you can set that here. So that's handy, but we don't need that for this demo. And finally, things like the permissions. So let's leave it as its default. And finally, you have a summary page. Yep, everything looks good. Let's go ahead and launch that. So now this is going to take a couple of minutes for it to launch. So it'll be interesting also if you wanted to keep the EC2 panel open. So behind the scene, as I mentioned, the Elastic Beanstalk, when it's trying to provision, it'll also provision EC2 nodes behind the scenes. So if we click on running instances, it should come up in maybe a couple of seconds or minutes. And in the meanwhile, you can take a look at the event log. It gives you kind of like health or a status, if you will, of the provisioning of the Elastic Beanstalk. Let's refresh that. Yep, and sure enough, we can see that as Elastic Beanstalk is provisioning the services, it's also provisioning the underlying EC2 instances. So again, we've not selected a load balance, highly available environment. So if we did select a VPC and various others, there's lots of other settings that we could have set. So that is load balance and various others, and we would have provisioned multiple EC2 instances. But for this purpose, a single EC2 instance. So we can see that's complete. It's finished setting it up, and this is why you want to give it a unique name in the wizard, so it's easy to detect. And here we can see that the provisioning is still going on. So let's give that some time. So I'm going to pause the video and we'll resume once that's done. Alright, it looks like the process is now complete. It should indicate through the icon here and the health status that your application has now been deployed. If you remember, we selected a sample application during the various screens in the wizard. So this is just a sample application that AWS provides, but we'll take a look at how we can deploy a custom Python Flask application. And you'll notice again that this is based on the stack that we selected, that it's used an Amazon Linux AMI running Python 3.6 behind it. There are a few interesting screens here provided by AWS, but we'll take a look at these monitoring screens once we deploy our application. So again, there's plenty to absorb here, but we'll come back to this once we take a look at the application itself. All right, so looking back at our agenda, so the first step was to create the AWS Beanstalk application, and we have just about done that. Last thing I forgot was, since we have deployed the sample application, let's take a look at that. So it generates a URL here for you dynamically. So if you click on that, you should see a UI similar to this come up. Again, this is because we have selected Python. So if you selected a different stack, it's bound to be different. But again, nonetheless, it's a good validation that our AWS application is running, and that's all well and good now. So let's close that, and now that we have completed this first step, so that's all done, let's go ahead and deploy our Flask application to AWS Beanstalk. Now I've covered an overview demo of Flask in a separate video, which you can find in the description below. So I'm not going to go through the details. So again, it's a really simple Hello World application. It's a REST application, and I'm using Flask RESTful, which is an extension to Flask, and nothing very fancy. All it really does is displaying a hello world when you point it to the root URI. So that's a very simple application. The key thing you will want to keep in mind, specifically when you're working with AWS Beanstalk, is that AWS Beanstalk and the way it's wired up with WSGI, the container, is that it expects a variable by the name application. So in most standard Flask applications, if you're familiar, the standard way is just to call it an app, an app. But AWS Beanstalk expects the variable name to be application. So instead of rewriting your entire code, and typically if you have decorated your code with @app dot something and various decorators, you don't have to change your code, just add an extra application. Again, this is less efficient, obviously. I mean, we have just created another variable, but that's not too bad given that we did not have to change anything else in your existing Flask application before you can upload that to AWS. And it's also a good idea to name your file as application.python.py. Again, that's only for the main application. So again, it's AWS Beanstalk is a little picky when it comes to some specifics of the variable and the file name. So that's pretty much all you need to do in terms of code. So again, if you're not comfortable with Flask, I would encourage you to take a look at my previous video, since I'm not going about it in a lot of detail. All right, so that's our application, just a very simple hello world. There are a few things that we need in order to upload and deploy our application to AWS Beanstalk. So the first thing that we will do is if you go to the terminal and to your folder, what I've done is I've created an environment here already. It's I'm using Conda, but I highly recommend you use virtualenv. Interestingly, AWS Beanstalk under the hood actually uses virtualenv, so it just keeps it consistent. So I've already got an environment here, and in that environment you'll want to install the dependencies. So in my case, the two dependencies are Flask, and make sure you do a pip install for Flask and then a pip install of Flask RESTful. So since I'm using these two libraries, so go ahead and install whatever libraries you need. Since I've already done that in advance, I'm not running it again. The next thing what we will need to do is to package a file. We will need to create a requirements.txt file. So the way you can do that is, if you're not familiar, if you do a pip freeze. So obviously I'm already in an environment, so when I run pip freeze, it gives me all the libraries that are currently in this environment. So again, we just needed Flask and Flask RESTful. Once you install that, these are the other dependencies. So we can either opt just to send this or send the whole thing, and should be fine. So the simplest way is just do a pip freeze and send that to requirements.txt. Did I get the spelling right? Yeah, hopefully. Yeah. All right. So we now have a file, requirements.txt, and sure enough, it's just what we've seen in the console. So that's the first resource that we need. The next thing that we need is, in order for us to upload and deploy the file, we need to package our code and the requirements into a zip file. So since I only have one Python file and one other file, I'm just going to go ahead and type it manually. So let's call it zip, and sorry, let's utilize zip, and let's call it demo .zip, and oops, if I can type zip. And in that we will add requirements and application. So obviously in the real world you'll have a fairly complex folder hierarchy, and you can maybe just do a find with excluding or including file types and pipe that to a zip. So here we go. We now have a zip file, and that's the zip file which we will then go ahead and go back to our application, and now we'll go ahead and upload and deploy our application. So let's say we have in that folder, we point that to the zip file that we just created. And let's just give it a label. Let's call it demo1, and let's go ahead and deploy. So behind the scene, what happens is that you have the AWS Beanstalk application was already created. So all it's doing right now is it's creating this application or a managed container specifically for your application, and it's just deploying that. So behind the scene, what it does is, if you're again familiar with the Flask, with Python, you'll already get a handle of what's happening behind the scenes. So since we have uploaded requirements.txt file, so behind the scene, it's running a pip install -r and requirements. Obviously, that's what's happening remotely, and behind the scene, it starts provisioning our application. So in some cases, we don't have any other dependencies. These are all dependencies that we can easily accomplish using simple pip commands. But in some cases, like you would have seen, like say, for example, if you're trying to install, say, a Postgres database, just doing a pip install and the Postgres wouldn't suffice. You will have to install, do something like an apt get install, or similar commands first. So again, all that is supported in Elastic Beanstalk, but I'm not covering that in this video. So let's see where we are. Okay, it's still provisioning the application, and looks like it's just completed deploying. So you can see that now the running version is demo 1, and that's the label that we provided, and the recent event shows everything is green. So let's go ahead and see if that's working. Nope. Let me just run that again. Oh, there we are. Sorry, I think I refreshed, or I didn't wait long enough. So sure enough, we can see that this is a hello world application. So let's see the raw data. So you remember from our code here, all it's really doing is it's doing a hello world, about and hello world. So sure enough, that's the expected behavior. Now we have successfully deployed our application. So in summary, if you package your Python files, any other resource files, and create a list of libraries that you need into a zip file and upload that to AWS Beanstalk, that's pretty much it. Alternatively, you can go ahead and use the Elastic Beanstalk command line interface. That's the other option as well. And typically you will once you start building applications, you'll most likely want to prefer using the CLI. Works very nicely with your development and Git workflows. So highly recommend you research the Elastic Beanstalk CLI. But further to that, let's go ahead and look at some of the other benefits and some of the other screens that we have in the AWS Beanstalk. So again, a lot of this has been configured through the wizard that we created initially. So we discussed that the benefits of the AWS Beanstalk is that it provides you all of these capabilities for us to scale our application. It provides auto scaling and various other capabilities, like we can scale it based on kind of like an on-demand scenario. So in some cases you want to scale up and scale down. So you have all of those capabilities available in AWS Beanstalk. So you can set what your schedule is. So at different times of the day, like during working hours, you might want to add additional capacity than non-working hours or peak hours, which you anticipate you can add more capacity in advance. So that's really a handy feature in AWS Beanstalk. There's quite a lot of configuration here, so we won't be going through that in a lot of detail, but typically when you're building an application for production, obviously we wouldn't be going through the wizard as we did, and much of this will come into play at that point in time. Let's take a look at some of the other screens that we have here. So obviously this was a very simple application, doesn't show a lot of details around it, and since we've just provisioned it, it's bound to be healthy, but it's handy to note that AWS Beanstalk gives us a wealth of capabilities to allow us to monitor the entire life cycle of the application, and also gives us an idea in terms of what the underlying resource utilization is. Since this is a really simple application, not doing anything much, so like I'm just calling it like a dozen times or so. It's not going to be immediate or very close to real time, but you'll find that it gives us a very clean view, not very limiting in my opinion, but it gives us a very clean view in terms of the utilization of the underlying resource. So again, this was a very simple hardware that we selected. So under the hood, it's still using a T1 micro, and we haven't made any heavy calls at this point in time, so it's not too stressed out the underlying hardware, but it gives us visibility to the underlying health of the application, and that's quite handy to have. So again, if we find that for the given resource it's not able to handle the load, it gives this view gives us a quick insight into whether we need to provision additional capacity or not. Again, there's quite a lot more in AWS Beanstalk, but for purposes of this video, I'm going to pause and wrap up this particular video. Hope you liked the video. Hope it's been helpful to help you get started using Flask and AWS Beanstalk. Thanks everyone for watching.